others. Can you please take us slowly so that we may be able to follow? In paragraph 36, deals with the roles and capabilities of the Gripen. Could you take us through that paragraph and explain to us in detail the roles and capabilities of the Gripen?
Chairperson, the Gripen is a supersonic, single-engine, dual and single-seat multi-role combat aircraft, and it is able, as was referred to earlier, can perform air defense surface attack, which includes both air-to-ground and air-to-sea attack, as well as what we term surveillance, which is both reconnaissance and electronic gathering of information in the same mission, and is also then globally interoperable. So this again comes back to what is then termed a multi or swing role aircraft, and it has proven itself to be able to do all of these. It also includes a modern defensive and offensive air defense features and equipment such as airborne radar. It has a very sophisticated air-to-air radar to guide its air-to-air missiles and also to do air interdiction and intercept. The RSA version of the Gripen was the first to receive a helmet-mounted display. Very briefly, a helmet-mounted display means that the pilot is projected on a helmet screen in his visor that he uses when he flies, is the information that is also required to fly the aircraft in the cockpit. So this is a further enhancement of, again, meaning that he can spend more and more time in high complex missions, not even having to look down into the cockpit. He can fly the aircraft whilst looking outside of the cockpit, doing the task at hand, and he has all the essential information that he can do that task without referring inside the cockpit. Most importantly, however, it means that he can aim with his head, his missiles and his weapons, not only in the direction that the aircraft is flying, as in the past, but with this capability, for example, if an enemy aircraft is in his rear sector and he picks that aircraft up, he can turn, designate through his helmet-mounted display that aircraft and fire his missile without looking back down in his cockpit. So you can imagine that this means that he can engage targets in a much wider field of view than before. So this is quite a considerable achievement of the program. And as I said, we were the first to receive, even before the Swedish Air Force, this capability. It is also fully integrated with all the other systems on the aircraft. And so I think the Air Force is very proud and to have this capability, and I think it was a very fine feather in the cap of the project to achieve that. It's a highly technological step for the Air Force. Then again, standoff and precision-guided munitions. Again, I did mention previously, and it can also carry the suite of what is termed non-precision bombs, or in some stages is referred to as dumb bombs because it has no guidance. But nowadays, modern munitions and bombs can be guided with laser or can be guided by radar. And the Gripen has the capability to also deliver these weapons. This comes back to the role primarily for peace enforcement and peacekeeping methods, where modern law and modern requirements are to absolutely minimize collateral damage. And so this is why you need to have a capability to, with high precision, deliver these weapons, which are very powerful but need to be targeted on the specific target. Also in the past, I think an example was used by General Malinga about bridges and such targets and airfields. These are extremely difficult targets to neutralize or destroy with what was termed non-precision weapons. So you will use these type of weapons for high strategic value targets where you want to make an impact in your interdiction and your airstrike to pave the way for your forces. Additionally, sometimes, of course, you don't want to destroy a target. The army might say to you, we don't want to destroy the bridge. We just want to prevent the enemy from using the bridge because we want to rebuild it and use it ourselves. Or, as an example, and these precision weapons can do exactly that. The weapon can then be guided and used to achieve the military objective and not just destroy the target. So that is an important capability to have in your inventory in modern warfare. And then it also carries a cannon, a 27mm cannon in the single-seater, not in the dual. Generally in air-to-air combat nowadays, most of the engagements would be with missiles, long-range missiles and short-range missiles. But from time to time, you can never assure that that will not end up in what we term close combat. And when you are below about 2,000 meters from the enemy aircraft, then the missile is not effective. And then you will go over to your cannons, and you need to use your cannons. So it's also good to retain the cannon capability on your aircraft. And then lastly, surveillance and targeting pods. These were delivered with the aircraft as well. And this gives the aircraft a day and night surveillance capability. It also records that information, and through the data link on the aircraft, that information in real time can be passed down to the ground forces or naval forces or to the headquarters from the aircraft. So this is the first time that the Air Force has had this level of capability. And in terms of the surveillance capability, it has a digital reconnaissance pod. So instead of this being what was termed in the past wet film, where the aircraft would photograph, land, then the photographs would have to be processed through quite a long sequence of processing, as your happy snaps do, and only then would the intelligence people be able to analyze that for intelligence purposes. Now, in the Gripen, this can be done real time, straight down to the analysts. They can do the analysis, and you have then this real-time capability. Alternatively, if you don't want to expose that, then the aircraft would land. But you can imagine, as your digital photographs, it goes a lot faster. And this is also a new technology that was introduced on the Gripen. The Cheetah only had a photo capability. It did not have, for example, the digital capability. So another enhancement. And then lastly, just to talk a little bit about the limited maritime role, the Gripen was not designed like the Buccaneer for dedicated long-range maritime strike, but it does have what we term a limited maritime capability. Just to put that in perspective, it is cleared for and can carry anti-shipping missiles. The one that it's cleared for currently is the RBM-15. It is a Swedish missile in a consortium. So it could be fitted at fairly short notice to the aircraft if required and then delivered. The aircraft itself, therefore, does give us that capability. Then, also on the aircraft, it has an active electronic warfare suite, and this is carried internally as opposed previously to our very early aircraft where it was external. The Cheetah also had an internal suite, and this gives the aircraft self-protection in a high-threat domain. It can carry the flares and chaff, which I did explain earlier, to defeat missiles and cannon fire, radar-guided cannon fire from the ground. But the active capability, digitally then, is also able to protect the aircraft and give some protection to other air assets that fly with the Gripen, be it other aircraft of our own or any other aircraft that would be flying in the vicinity as well. And then it can carry 3 long-range fuel tanks under the wings and under the belly. This gives the aircraft extended range and also would be able then to be sent into an area with long range with those tanks on. Once in field of operation, if there are operations closer by, then those tanks can be removed, and of course more bombs or more missiles can be loaded on the aircraft. So you have a large flexibility of configurations which you can put on this aircraft to suit the operational commander's intent in the area. And yet you can fly there with the 3 tanks to get the range to go far to employ the aircraft. I will talk a little bit more about that a little bit later. And then, of course, additional to that, the aircraft can be refueled in the air, as I showed you with the photographs the other day. And, of course, this just gives enormous range then to these aircraft, should they be required to carry out roles at that distance in national interest. A very important feature of the Gripen is also the ability to do what we call hot refueling on the ground, Chairman. This means that the aircraft can land off a typical air policing or air defense type of role, having been in the air for approximately between 1 hour 40 and 2 hours, and taxi in with the air crew in the cockpit. The ground crew can then refuel the aircraft on the ground through the air-to-air refueling probe while the engine is still running, all the systems are on. It is an extremely quick turnaround time, and so that asset can get back in the air at very short notice. Previously, our aircraft would have to shut down, and the pilots would have to climb out the aircraft, the refueling would have to take place, and then the aircrew would climb back in again, start up, and leave. And so you can imagine what a force multiplier that would be in a high-intensity situation, or where you have fewer aircraft, but you can put them on station so much quicker. Quite a large growth path that we've had in the aircraft compared to our previous fighter aircraft which we have had. And then the last part is nowadays, of course, fighting at night is a very important capability to have. And the Gripen is fully what we call night vision goggle compatible. The cockpit is designed to be able to operate with night vision goggles. This gives the aircrew the ability to see at night through these night vision goggles. This technology is well established in the Air Force in our helicopter line and has been used extensively, but this is the first time that we will have this capability on our fighter aircraft. It was not delivered as part of the project. The aircraft was delivered to be compatible, but it will be the Air Force then that will deliver the actual goggles, and that is in process of being investigated. So very shortly, we will also have this capability then on Gripen and be able to utilize that, which will expand quite largely the night capability of this platform. The system consisted then of 26 aircraft, 17 single-seater and 9 dual-seat aircraft. The reason for that mix was a balance between the fact that, as I said earlier, some training does still need to take place, even though we have the leading fighter trainer on the Gripen, so that the instructor can just train the new pilot on Gripen in all of these systems that are in the aircraft and give him his initial flying conversion. But a much more important role of this dual aircraft is in the command and control domain. Because when you start to work with radars and mission controllers, you've got your full suite of multi-role aircraft requirement, then for some missions, we're finding now, as like other air forces, that the limitation actually then becomes the ability of a single crew member to carry all of this out. And so we found that the dual is ideal by putting 2 pilots in the cockpit, or a pilot and what we term a strike navigator, who would be able to split the responsibilities and so use the platform even more efficiently, particularly where you can use the dual as a type of airborne command and control aircraft. So you would have this aircraft as your type of mission control, and then other Hawks and other Gripens, but possibly even then Hawks or helicopters or other aircraft in a very complex mission where the commander can actually be in the air in a very sophisticated aircraft monitoring what is going on electronically. And I know this is very technical, but I can assure you that in our domain, this is a major step forward of this new equipment. And I'll talk a little bit how we used it when I get to the exercises and operations that we have been in so far. Also, as I explained, it's not only the aircraft. This aircraft also came with a very modern and very sophisticated simulator, which is placed at the squadron. There are 2 stations or 2 simulators. They are called squadron level trainers. And this is both for air and ground crews who can train on this equipment at a centralized training school. Because we got the Hawk and Gripen at the same time, we could actually have one centralized training school to do all the ground training. It's computer-based. There is also virtual aircraft training where the technicians can virtually on the aircraft practice skills on a computer. This has been centralized. So instead of now duplicating, because we're on the same base, we could have a large cost saving by having this centralized training center. And it is fully computerized, and this is, as I said, situated on the base for both of the crews. In terms of the simulators, these were then split. And the reason for that is that on the lead-in fighter trainer, the simulator is mainly used to teach him to fly the aeroplane and do skills training. On the Gripen, however, we acquired what was termed squadron-level trainers, 2 of them. The reason being that flying the aircraft is not as difficult, and by now he is already a skilled and trained fighter pilot. So these were then aimed at teaching him the complex systems in the airplane. The other advantage is that these 2 aircraft on the ground can be linked with aircraft in the air. So you only have to put up, for example, if you want to have or practice a air combat scenario with 4 aircraft, you only have to put 2 in the air. The other 2 can be flown against digitally and electronically from the ground in these simulators. This is an enormous saving on training. And so, again, this has been a step forward. The Cheetah also had a very good simulator. It had what was termed a full dome simulator, because in those days, the jump in flying the aircraft was much larger because of the older airframe technology. But it did have a very good simulator as well, but not to the level where we could do what we can do with the Gripen now, with this type of new simulator. We have also found out that we can, and again, this is what I referred to earlier, you only really get to know the full magnitude of this equipment when you start to use it. And in my words, I say you give it to these youngsters. They know this stuff, how to use this new modern equipment. We've now actually got the pilots and the engineers on the base to find a way to also link the Hawk simulator into this scenario. So now we can have Gripens, Hawks, Gripen simulators, Hawk simulators in quite a complex training scenario, all linked, and also have mission controllers involved. This has just put a new world into training and into capability. And again, because it is interoperable, we've also been able to include a lot of modeling and simulation into these systems, which means that you can model and simulate tactics and doctrine through these mechanisms without even flying. So by the time the aircrew go out to fly, in the past, I don't want to say when I was young or when I was there, but I mean, we had to go and do all this in the air at great cost to learn tactics and to learn doctrine. There was no modeling and simulation, and that you learned it by error or by trial and error in your training. Now, a lot of that can be done through these systems with the pilots actually flying first on computers and other mechanisms. And by the time that the pilot climbs into the cockpit of this aircraft, he is already very well rehearsed and practiced. It's almost, the term I would use is he's going to the opera. The opera now plays. Yes, he still has to apply his mind. He still has to be take it to the final job in the air. But that gap has been largely narrowed. And to allude to that as well, often we hear the critics about flying hours per year, and I will come to that later. This is the reason why you can still have a safe combat pilot flying much less hours. I don't say no hours, and I don't say too little, but a lot less hours are required now to actually be flown in the aircraft than on systems in the past. So from a national economic point of view, these are expensive. You heard the Navy say navies are expensive. Fighters are expensive. But I can assure the Commission that we do all we can to make sure that when that aircrew member climbs in that cockpit to fly that hour, he has made maximum use of all other training aids and methods. The average price or cost of a simulator hour is around about 6% of an aircraft hour. And yet you can achieve a lot. This is not to say that you can achieve that level by not flying and only using simulators. And some air forces have made the error of overemphasizing that But a good balance, which I believe we will find as we go along, will be found. But an enormous step forward and saving that we have on these modern systems. Also, to add to this, then, of course, delivered is all of the ground support equipment for the aircraft. This includes test equipment. And here, in terms of the Gripen, a large part of the test equipment and logistic support required was placed on the base on site. So this means that a large part of the servicing and maintenance can also be done on site. And again, where in the past the technicians had to spend quite a lot of time fault finding if there was something wrong with the aircraft, the modern systems now can be plugged into modern computer systems, and the analysis is done quickly and efficiently. It's very much the same as your motor car now. If you drive probably an early 2000 model Volkswagen, as I do, but if I had to get a modern Jetta CC and take it in for a service, I know that it gets plugged into quite a sophisticated piece of equipment and is fault found very accurately. And so the same principle applies here, that it is a very much more modern system and able to reduce the time and get accurately to the point at which repairs and other such matters need to be carried out. And then the logistics package, which was also delivered. This included spares for the aircraft. In these sanctions days, when we had to acquire aircraft, we had to acquire what was termed lifelong spares. That meant that because we were getting the aircraft under those conditions, we bought enormous stocks of spares with the aircraft. And I think the Navy also alluded to this. That was necessary because of sanctions, but that is not cost effective. So now you will try to minimize the level of spares and stock depending on threat levels, availability. You will manage that. And that was a large part of the project, was to make sure that we did not unnecessarily expend funds on logistics that we could expend elsewhere. That's why, again, I come back to why you need your teams to be very much involved and the Air Force to be involved through the project process. And so it's all a matter of balance between what you put the funds into the aircraft, into test equipment, into logistics, etc. And there is a very, very efficient and complex process which gets done during the project. And then the Air Force, once it gets these initial spares, it will learn the aircraft and also correct that in the second round. During the sanctions, when we faced, for example, the Mirage F1s out, there were still many Mirage F1 spares that were never used because that was the situation of the day. So I can assure that in this case, when the aircraft were delivered, the spares package was carefully monitored and as accurately as possible predicted for the initial delivery. And from now on, it's open market and the spares would then be ordered as required from that point on. Again, I just wanted to show that this capability does not only lie in the aircraft, it lies in the aircrew, the aircraft, and all the associated equipment as well. And lastly, on the Gripen, we also delivered one aircraft, which we termed the Flight Test Instrumented Aircraft. This is one of the two-seater aircraft, number 3901. This aircraft was acquired for the specific purpose of being a test platform. This means that the aircraft can accommodate highly accurate and sophisticated flight test instrumentation. If you see the aircraft and open it up, you'll see a whole lot of orange boxes and orange wires inside. That tells you it's unique. It's only flown by test pilots and test engineers. We use this aircraft, Chair, to do continual test flying on our fleet with our own test pilots and our own test flight center. And this, again, was a technology improvement for us as well. And if we want to now, for example, make small changes or make a configuration change on this aircraft, we can do it locally in South Africa with our own capabilities. And then the SAB, in this case, would be given all of the data. They will check it for us to make sure that we have not impacted on the highly complex part of the aircraft, the fly-by-wire or something like that. But they would then endorse this change, and then it means that this could be done locally instead of the whole program having to be done in Sweden with one of their aircraft at a very high cost. And we have already done such work, not only then for ourselves, but this also gives the ability to our local industry to make use of these aircraft, to help them in some of their campaigns as well. And this has happened already on Gripen. So I thought that was also an added point in terms of the capability of the Gripen. And then, Chair, I'd like to go to the Hawk. Sorry.
Before you go to the Hawk, General, does the fact that other countries have also bought the Gripen also assist us in terms of the maintenance issues?
Yes, sorry, I'll allude to that a little bit later at the user group, but I can cover the question now. Certainly, the other countries that have the Gripen currently is the Swedish Air Force, who was obviously the initial Air Force home country to fly the aircraft. And they acquired roughly 250 aircraft of the AB type. This was not of the export baseline version. They have since converted a lot of these to the export baseline for their own use. We were then the first launch customer for the export version, and we acquired the 26. Then the Czech Republic and Hungary, more or less at the same time, found that they had quite a lot of Eastern aircraft, of the Su, Sukhoi, and MiG type of aircraft. And they also, as you know, have the L-159, which is their leading fighter trainer, which we also evaluated under the lift. But these aircraft were not NATO compatible. And when they became part of the European Union, then the air policing role in NATO is shared between many countries. And they then found that these aircraft were not as multi-role and also able to carry out this air policing role to the satisfaction that would be required. And so they then, for this purpose, and also to give them an interim period before they would acquire their new fighters, they then went and engaged in a lease option through the Swedish government with Saab, and they have leased Gripen aircraft for their two countries with an option to then go over to a buy. And as I referred to earlier, this is probably a good way to go when one is in a transit or in an interim period, or you need a new requirement for a limited period of time. A number of European countries have done this. And then the next country to acquire the Gripen chair was Thailand. They acquired 12 aircraft in two tranches of 6, and interestingly enough, they also acquired an airborne command post and aircraft that can do command and control in the air, which is called the Saab Erie Eye aircraft. And this was a package that they have acquired. Their first 6 aircraft have been delivered. Their next 6 aircraft will be delivered shortly. And this airborne capability, our Gripens can also operate with this airborne capability, and it forms a total system. This, in other words, we are referred to the radar control currently that we do from the ground. You can also put that capability in the air, in what's termed an airborne platform for this task. And Thailand acquired that as well. This, of course, could be a future growth for our Gripens in the event that the need was for us to go to that. This, again, just expands the area of operations and the capability of the system as well. And then the Gripen is currently being bid in Brazil. They are also busy replacing their fighter. But during this period of the bid in Switzerland and also in India, the Swedish government and Saab, or entered into a contract with Saab to go for the next version of Gripen, which is termed the Gripen NG, New Generation Gripen. This is an upgrade of the current Gripen that we have. And so I think we can allude to the fact that therefore it proves that the Gripen has a large growth capability. This aircraft will then still be a light fighter, but will move closer towards the medium fighter range. And it is now competing with the French Rafale as the final 2 down selections. The American aircraft as well as the Typhoon has fallen out of that competition. and it's down to a two-way race at the moment in Brazil between the Rafale, which is a medium fighter, and the Gripen. Again showing, in my view, my personal opinion, the fact that medium fighters are becoming extremely expensive aircraft and assets to acquire and to maintain. Even if a country like Brazil, which we know is very large, is considering also going for a light fighter. And then the other bid that the Gripen has been successful, also the NG version, is in Switzerland, which is very interesting. In Switzerland, the selection of the type of aircraft is completed first in toto, and the Gripen has been selected in Switzerland. It was also in competition with the Rafale and the Eurofighter, so the Swiss have also decided to go for a light fighter aircraft and not a medium fighter. And I think I explained yesterday that Switzerland has a strong defense force, although they are neutral. However, in Switzerland, what happens is once that decision has been made as the military choice, then it has to go through the political process and even to a referendum in Switzerland, which decides whether to replace the capability or not. And that is in process at the moment, and that is the last step. So we could possibly have even more aircraft joining the Gripen user group, which we belong to as South Africa as well. So to come back then to your question, yes, the more Gripens that are acquired is good for us because it means that your economy of scale on your spares, on your ability to then have pooling of armament when you acquire armament. There are a lot of advantages when there are more and more aircraft of that type that are acquired by various air forces. And also, of course, through the user group, which we belong to and have been very active in, being the launch customer, you learn a lot from the other users. And, of course, having Thailand, very, very humid part of the world, very different part of the world. We have South Africa, hot and high, Africa. You have 2 European countries, 1 Baltic country, and possibly a South American country. So in terms of learning about operating of this aircraft from a technical and engineering operational is very advantageous for any air force to have other users of the aircraft, if that answers the question, Chair.
And these capabilities that you've alluded to in paragraph 36 and 37, were they standard in the sense that did we have to pay any extra for these capabilities?
No, Chair. The STPs, as you know, were given a ceiling amount. That ceiling amount was a fixed amount from the time that the approvals were done by Cabinet, and therefore on those funds were then ring-fenced by Treasury. So there could be no funding on the capital account outside. The challenge of the project team then, and out of this process where I again yesterday said you want the project team to be involved right through, one of the main roles then, once the decision is taken, in this case we were going to acquire the Gripen, then the project team goes into a different approach. Now we know the product. We know the aircraft fairly well. We know the financial baseline. We know the delivery. And the job of the project team is then to ensure that we get the very best we can for the amount that is spent on that aircraft to meet the requirement of the Air Force. That is an important role that the project team continually is monitored, it's audited on, and that is why you report back regularly to the various boards on a regular basis and is audited throughout the process to ensure that that occurs. So I can then confirm that whatever was delivered had to be delivered within the ring-fenced amount. If you may remember, and obviously this will come out much more from the financials and the Treasury side, but there were certain aspects of the program that were not, call it, funded by the additional amount because the government had come in to supplement the long-term master plan of the department. So there was some funding that was additionally added for program management and other matters that came, yes, from the end user as well. But in terms of the deliverables, it was ring-fenced, and again, like in all projects, you have to balance the resources. And perhaps I should say it now, I had it a bit later. But if you remember, during the period of the negotiations under the International Office negotiating team, there was ongoing debate to contractually find this balance already. Log, number of aircraft, etc. And it went through a number of iterations, which in my personal view was an excellent process to go through. I can assure you, as the project team, we were questioned on each and every aspect by that team to make sure that this balance and resource balancing occurred already at that point. And one of the affordability measures that was taken was the IONT came back via the project team to the Air Force to say, look, we need to review some of the functionality or the logistics or the numbers. And this was done in debate between the parties and then back through the IONT to the contractor in this case. And certain functionalities were then limited and stated as such. The Air Force accepted that and then said we must try to meet those requirements. And I can again compliment the project team that towards the end of the program, the decision was taken to reduce the aircraft from 28 to 26, but to rather deliver the full capability on the aircraft. This meant that the aircraft that we have received then did deliver the requirements that the Air Force said were mandatory at that point in time. And recently, when we used the aircraft for an operation, it was very interesting that the officer commanding of that squadron said to me, you know, it's very good that we delivered that last bit of capability. I can't elaborate in total on it, but it actually meant that they could carry out the mission a lot more effectively and efficiently. So again, I think I want to give the assurance that this is an ongoing challenge. You have a limited resource, but you try to make it the best at the end of the day for the end user and, of course, for the country. And this is a classic example where, in my opinion, that worked very well. Thank you.
Thanks, General. We acquired about 9 dual seats Gripens. Now, the critics have indicated that the dual-seater Gripen were not considered to be fully combat compliant with the South African circumstances. Can you comment on that?
The only difference between the single and the dual-seater is that you need more space to put the second cockpit and the ejection seat, so it carries less fuel than the single-seater, but not by a large amount. And the other difference is, due to that, the cannon is not on the dual-seater aircraft. And I explained earlier that the only time the cannon is of importance is in close-in combat, okay, which will not happen very often. And secondly, would be then in a type of close air support situation close to the ground, where in all likelihood you would not risk using a dual-seater. You would rather use the single-seater in that type of operation. That is a balance that you have to make. You cannot have a light fighter and then want it all. Then you must buy a medium fighter. And we've already been to that debate. So my answer would be, and flying the aircraft, and we've flown the duals and the solos, and found that in normal operations there is not a large difference in range and performance. I cannot give the exact numbers in percentage, but I would tell you that it is not a major issue for us to operate the 2 aircraft. And because we have 17 singles and only 9 dual, we have adequate aircraft to make sure that the mission requirement will be met with the mix of the aircraft. And I've already alluded to the advantages of having the more dual-seater aircraft. So to say that it is only a training aircraft is not correct at all. It is a fully operational platform, but with some restrictions relative to the single-seater. Chair, if that answers your question, sir.
Thanks, General. Now, during the presentation, you also took us through some capabilities of the Gripens. Amongst others was the range, that the Gripen has a 1,200 kilometers range. What is the advantage of that?
Yes, I think there was a number of people who also had some criticism regarding the Gripen. Again, being a light fighter, and it was the same with the Mirage 3 and the Cheetah, you will find that the underwing centerline tank, fuel tank, you can almost consider as being part of internal fuel. You will virtually always see a Gripen, other than in an air show or for a very short sort of type of operation where you want minimum drag on the aircraft, then you will carry the external tank. The big advantage of the Gripen over the previous aircraft is because it has the fly-by-wire and is digitally controlled. This means that the aircraft is flown in what we call a super economic role at all times, controlled by this computer. So it is much less of a factor now of carrying this centerline tank in terms of the performance of the aircraft. Also on previous aircraft, this tank limited the performance of the aircraft in terms of G maneuvering and also in terms of certain maneuvers. And this is also overcome by having a modern fly-by-wire system. If you had to look at most of the medium fighters around, this is common to all the aircraft. If you want to have long range with internal fuel only, then you must acquire a medium fighter with the same implications. However, on the Gripen, again, you can also fit underwing tanks, as I alluded to, if required to go further than just with the belly tank. So range is a difficult one because you've got what I termed ferry range, in which case the aircraft can deploy very far. An example was that to go for again, I'm going a bit early here, but during the recent operation in Kar, the aircraft were able to go into that scenario with only one landing. I can assure you that would not have occurred with previous aircraft. So we have proven that the Gripen has legs, and it can go, that's on ferry. Obviously, when you now have to carry a full weapon load, then you will not be able to go as far, but again, you will carry your centerline tank, and you will then plan the mission accordingly to how much fuel is required. So in the presentation, you will remember I said that range is in a combat area range. It is not the ferry range of the aircraft. The ferry range of the aircraft, where it purely puts tanks on and gets into the area, is a lot greater than the other aircraft. The new engine, which is also digitally controlled, has what is termed an eco-cruise mode, which previous engines did not have, and most modern light fighters have them now. That means that the aircraft can what is termed super cruise, similar to airlines, which are in the same bracket where they can fly at high speed, around about Mach 0.8, which is approximately 16 kilometers per minute, but they are flying in a highly efficient engine mode where you get minimum fuel usage. So these are, again, the advantages of modern equipment, modern engine technology, which we have in the aircraft. So I can, again, assure the Commission and the nation that these aircraft have a longer range that we've tested than what we expected when we did the evaluations on the aircraft. They have certainly met the range expectations. Thank you. Chair.
General, this new Gripen, the new generation, can we be able to upgrade the current Gripens to that?
I think, yes, you would be able to upgrade our Gripens to the new generation. What we have not done, though, is asked Saab to give us the cost. My personal view is it could be more expensive than just acquiring the NG as either additional to or to replace some of at any future point in the process. But I cannot sit here and say to you, anything is possible. An engineer will tell you you can do anything. He will redesign anything, but at a cost and at time. But having been through the project and understood this process, my personal opinion is it would be a close trade-off as to whether you would upgrade or rather than even maybe acquire, because then you would get the aircraft as designed by the OEM as is and delivered. The Swedish Air Force are going to continue to fly both types and have committed, the government has committed to the new generation aircraft, yes. So it is the best answer I can give on that one, but it is not a confirmed answer in terms of engaging with Saab on this subject. What I can confirm, however, is that the upgrade to the current Gripen, in terms of its mission capability is now done mainly through software. So what I'm trying to say is in the past, when you wanted to, of course, change your aircraft or upgrade it, you virtually had to do a major change, as was on the Cheetah. Nowadays, the update to the capability is done much more regularly because it's mainly a software upgrade, similar to what your home computer would be updated. Not as simple, but already there is regular updates which SAAB put out, which you can either accept or not at cost, and you can upgrade and choose to upgrade to a higher level of computerization and therefore capability. And because we are part of this user group, we have access to this with the other users as well. So I would say that is also an advantage which previous systems, of course, analog systems could not do. Thank you, Chair.
General, critics have also raised issues about whether this equipment, including the Gripens, are women or gender friendly. What's your comment on that?
Both aircraft and modern aircraft that were delivered were not necessarily designed for all what we term in aviation anthropometrical data or anthropometrical models. The most extensive work done on this was by the Royal Air Force, and they talk about a 2 to 97 percentile in this domain. This is done by aviation medicine people, doctors and specialists. But the bottom line is what they say is they'll design an aircraft that anybody in the demographics of that country that they either use their own or a worldwide one, and the RAF is the standard. Our aircraft were delivered to that standard, 3 to 97 percentile, meaning that within 3 to 97 percentile, it goes about the ejection seat, not necessarily only the cockpit. A large part is the ejection seat, because it is obviously a very critical component, and also the cockpit layout. These measure, in other words, arm length, leg length, mass, head size, etc., because of the fact that the cockpit is then designed to accommodate that size of person, etc. So when we do our flying medical as pilots, you get measured. In fact, you get measured electronically nowadays as well. Everything is going digital. And so this would then decide whether or not you pass your medical to become, first of all, a pilot, and then you have also, when you fly, you have restrictions on the ejection seat. Fortunately for us in the combat line, to fly the PC-7, it's got an ejection seat, so this is done early. So, but should any gender or race fit that profile, then it is no problem, they can fly the aircraft. So what we found then is we have so far managed to train, we have 3 female fighter pilots currently. One is fully qualified on Gripen and operational and has flown in exercises. And we had no problems. We have proven that from a gender perspective, there is no restriction on women in South Africa to become fighter pilots, and we're very proud of that. Then we have a strike navigator on Hawk, who fly in the rear seat, and they navigate and they operate many of the systems, and they also train on the Hawk. And she is currently on Hawk and is about to go and do her navigator instructor's course at the moment. And then we have just selected a female pilot off the Astra course. She's currently preparing for the course, and she will start her training on Hawk shortly. So we have then trained 3. I will show the representativity of the current strength, but we have trained members of all of the groups in South Africa, and we have not had any problem to train them either on the Hawk or on the Gripen. What we did find is that with the females being lighter, also some of the candidates who we could not accept onto the aircraft, not for the ejection seat, but for some of the other limitations of mass in the cockpit for ejection, we could not accept into the combat line or for selection. And this now has then become a gap, And this gap is being filled currently by a project which will lower the bottom end mass for entry onto these seats on the aircraft, as well as increase the upper end. And the upper end of our problem was actually our middle-aged fighter pilots, which started to not be able to contain their mass and did not attend their weight watchers and physical training as regularly as they should have, but now have got themselves where you have some of our aircrew who still have years left in the cockpit, but can no longer fly the Gripen, for example, which has a lower mass top end than the Hawk, but a lower bottom end than the Gripen. These are being corrected now through a project, and we are addressing this. So in the future, we will make sure then that even a wider group of members, it's not a lot that can't, but we want to make sure that we do not stand in the way of anyone going into this career and achieving that. But I can say today that we have trained Hawk and on Gripen members of both genders and all groups in the country. We do not foresee a problem of that in the future. Chair.
So you are assuring our South African women not to be worried by that?
Not at all, please. They can come. I can assure you that when Our Lady flew in this exercise with some other countries, their eyes went very wide when they saw that she does not stand back for any of her male counterparts when it comes to combat or to doing the job. And she's a great ambassador for us as well. She's now gone for an instructor's course. She will be an instructor in a year's time back on the Astra. She will then go to Hawk as a pilot attack instructor. And I see no reason why she couldn't become a future officer commanding of 2 Squadron. Currently, our officer commanding of 2 Squadron is Lieutenant Colonel Musam Bakota, who is one of our pilots who first joined the Air Force. He flew Impalas and Cheetahs. He then went through Hawks and Gripens. Last year, he completed the test pilot's course in the USA. And he came second on that international test pilot's course, and he's currently our OC of 2 Squadron, of which we are enormously proud. So there are no barriers, we believe, from any side in the Air Force's fighter line. Thank you, Chair.
General, you also mentioned that the service ceiling on the Gripen is 15,000, is it Mach?
Service ceiling on the Gripen is 50,000 feet. Sorry, 50,000 feet.
What is the advantage of that?
Most fighters operate in the band of what we call the stratosphere, actually, for those that are geographical of mind. That is the highest level at which airliners and most high-performance aircraft fly, and hence I explained the Mach number. Above 50,000 feet, again, if you want to operate up to the 65,000, then you need to acquire a medium fighter. But the performance of aircraft above 50,000 feet, even super aircraft, unless they are specifically designed to fly in that domain, starts to reduce quite considerably. So you would therefore, again, drive your cost up very high if you designed and tried to make an aircraft operate highly efficiently above that ceiling. There are aircraft such as the reconnaissance aircraft. You might have heard of the SR-71 or U-2, which are specific stealth type of aircraft for very high altitude surveillance. These aircraft, however, perform well at that altitude and are designed. But they don't want to be caught below about 40,000 feet because then they're not designed for that. So in terms of 50,000 feet, the Cheetahs could operate up to about the same, and the Hawk can operate up to 48,000 feet. So this is normal envelope in terms of altitude for typical light or trainer type of fighter aircraft. Chair.
In terms of armaments, which the Gripens can carry, you indicated that it can carry one 27mm Mosor BK-27 cannon. Am I correct?
The single-seater, that is correct, Chair.
Now, do we buy this armament separately, or they come with the Gripens?
The cannon, all the cannon, the pylons, the drop tanks, all were part of the deliverable of the aircraft. It's what's called ancillary equipment. It comes with the aircraft. However, the rounds that fire in the cannon and the bombs that are dropped are not part of the project deliverable. Those are bought on an ongoing basis by the department or the Air Force under the operating budget. So the 27 millimeter rounds currently are acquired from, we use the German Air Force stock because this cannon is very common. It's also on many, it's in the Eurofighter, it was in the many other of the older generation aircraft. So it is a very well proven cannon, and the ammunition is made in a number of parts of the world, and obviously this will be done through the normal contracting and the most cost-effective solution found to acquire the rounds on this aircraft.
And another capability is that the Gripen single-seater can carry 6 short-range infrared AA missiles. They also came with as a package.
No. These short-range missiles were acquired under a separate project. Currently, we are using what we term an interim missile solution for Gripen. It's the RST missile, which was cleared already on the aircraft. And then a project which has been running for a while now, Project Asahai, is a collaborative project with Brazil and Denel Dynamics in South Africa, supported by the DOD and the Brazilian industry, as well as ours. And this will deliver a South African-Brazilian combined missile for the Gripen. It's called the A-Data, and this will be our permanent missile on our new Gripen aircraft. This, again, starts to show, and I don't want to go into all the detail of direct industrial participation because many of my colleagues will talk about that, but this is one of, the advantages of buying or acquiring a modern aircraft such as this, because it also then creates opportunity for other technologies and call it indirect participation and industrial activity for such a platform. And that missile is currently scheduled to be delivered onto Gripen in 2015. And that will then replace our interim solution, which is the one that we imported under a project, namely the RST. So this also, very importantly, gives us a second option, because as you know, on a strategic asset such as these aircraft and same on Navy ships, if at all possible, you don't only want to have one source. Because if you have one source, and you, in the modern world, then need to carry out certain activities in national interest, you could be limited, restricted, or even in the worst case, prevented from doing so. So wherever possible, you try to make sure that you also then maximize your local capability in order to support you in this case. And of course, it will be more, once acquired, it will then be more cost effective for us because we will be able to maintain that capability in the country. And I think that this program is so far been very successful, Chair, as far as I know. We only bought a limited number. I won't say how many, but we bought a limited number again because it was an interim solution to see us until now. We could test the aircraft, and we also, of course, needed it for some of the operations that we've been involved in. Thank you, Chair.
And there's also provision for the Gripen to carry about 4 medium-range electromagnetic AA missiles. Can you speak on that?
Yes, currently the aircraft is fully capable of carrying a medium-range aircraft, a medium-range missile, termed beyond visual range missile. Currently, the aircraft, this was not part of the program, the supply of those missiles, and similarly, this is a requirement that is registered and is going through the process within the department. Chair.
And what is the difference between the short-range and medium-range missiles?
Short-range missiles are for what we call within visual range. In other words, you see the aircraft. And with modern short-range missiles, they've again, like all capabilities and technologies, they've actually also now have a call it outside of visual range. But a true beyond visual range missile is a very long-range missile which is fired by the aircraft either once radar lock-on is gained at long range, and then you also get a version of modern BVR missiles that actually launch off the aircraft and lock onto the aircraft after launch. So it's controlled by the aircraft that launches this missile for a certain period of time, after which the missile itself engages the target and then tracks the target itself. Very highly complex. So these are the capabilities that are out there and are available on certain aircraft, medium fighters as well as light fighters in the world currently. So I don't know if I hope that puts that into perspective. Basically, it goes about the capability of tracking, the radar, and then of course, much extended range that this missile can be fired at, and that is the term beyond visual range versus within visual range missile. Thank you, or short range and long range. Chair.
Thank you, Chair. I see it's almost about 11:10. General Bain has pleaded with me that we should maybe adjourn it around this time, having reached the age of beyond 40.
Advocate Parker, I missed your proposal.
My proposal is to adjourn for tea. I was requested by General Bain to at least push him until this time, as he has other needs that he needs to address.
I heard you referring to the age of over 40. I hope you're not referring to me. You're not referring to me when you said over 40. Okay, then let's adjourn for 15 to 20 minutes. Thank you.
Okay. Amount from the time that the approvals were done by Cabinet, and therefore on those funds were then ring-fenced by Treasury. So there could be no funding on the capital account outside. The the challenge of the project team then, and out of this process where I again yesterday said you want the project team to be involved right through, one of the main roles then, once the decision is taken, in this case we were going to acquire the Gripen, then the project team goes into a different approach. Now we know the product. We know the aircraft fairly well. We know the financial baseline. We know the delivery. And the job of the project team is then to ensure that we get the very best we can for the amount that is spent on that aircraft to meet the requirement of the Air Force. That is an important role that the project team continually is monitored, it's audited on, and that is why you report back regularly to the various boards on a regular basis and is audited throughout the process to ensure that that occurs. So I can then confirm that whatever was delivered had to be delivered within the ring-fenced amount. If you may remember, and obviously this will come out much more from the financials and the treasury side, but there were certain aspects of the program that were not, call it, funded by the additional amount because the government had come in to supplement the long-term master plan of the department. So there was some funding that was additionally added for program management and other matters that came, yes, from the end user as well. But in terms of the deliverables, it was ring-fenced, and again, like in all projects, you have to balance the resources. And perhaps I should say it now, I had it a bit later. But if you remember, during the period of the negotiations under the International Office negotiating team, there was ongoing debate to contractually find this balance already. Log, number of aircraft, etc. And it went through a number of iterations, which in my personal view was an excellent process to go through. I can assure you as the project team, we were questioned on each and every aspect by that team to make sure that this balance and resource balancing occurred already at that point. And one of the affordability measures that was taken was the IONT came back via the project team to the Air Force to say, look, we need to review some of the functionality or the logistics or the numbers. And this was done in debate between the parties and then back through the IONT to the contractor in this case. And certain functionalities were then limited and stated as such. The Air Force accepted that and then said we must try to meet those requirements. And I can again compliment the project team that towards the end of the program, the decision was taken to reduce the aircraft from 28 to 26, but to rather deliver the full capability on the aircraft. This meant that the aircraft that we have received then did deliver the requirements that the Air Force said were mandatory at that point in time. And recently, when we used the aircraft for an operation, it was very interesting that the officer commanding of that squadron said to me, you know, it's very good that we delivered that last bit of capability. I can't elaborate in total on it, but it actually meant that they could carry out the mission a lot more effectively and efficiently. So again, I think I want to give the assurance that this is an ongoing challenge. You have a limited resource, but you try to make it the best at the end of the day for the end user and, of course, for the country. And this is a classic example where, in my opinion, that worked very well. Thank you. Both aircraft and modern aircraft that were delivered were not necessarily designed for all what we term in aviation anthropometrical data or anthropometrical models. The most extensive work done on this was by the Royal Air Force, and they talk about a 2 to 97 percentile in this domain. This is done by aviation medicine people, doctors and specialists. But the bottom line is what they say is they'll design an aircraft that anybody in the demographics of that country that they either use their own or a worldwide one, and the RAF is the standard. Our aircraft were delivered to that standard, 3 to 97 percentile, meaning that within 3 to 97 percentile, it goes about the ejection seat, not necessarily only the cockpit. A large part is the ejection seat, because it is obviously a very critical component, and also the cockpit layout. These measure, in other words, arm length, leg length, mass, head size, etc., because of the fact that the cockpit is then designed to accommodate that size of person, etc. So when we do our flying medical as pilots, you get measured. In fact, you get measured electronically nowadays as well. Everything is going digital. And so this would then decide whether or not you pass your medical to become, first of all, a pilot, and then you have also, when you fly, you have restrictions on the ejection seat. Fortunately for us in the combat line, to fly the PC-7, it's got an ejection seat, so this is done early. So, but should any gender or race fit that profile, then it is no problem, they can fly the aircraft. So what we found then is we have so far managed to train, we have 3 female fighter pilots currently. One is fully qualified on Gripen and operational and has flown in exercises. And we had no problems. We have proven that from a gender perspective, there is no restriction on women in South Africa to become fighter pilots, and we're very proud of that. Then we have a strike navigator on Hawk, who flies females being lighter. Also, some of the candidates who we could not accept onto the aircraft, not for the ejection seat, but for some of the other limitations of mass in the cockpit for ejection, we could not accept into the combat line or for selection. And this now has then become a gap, and this gap is being filled currently by a project which will lower the bottom end mass for entry onto these seats on the aircraft, as well as increase the upper end. And the upper end of our problem was actually our middle-aged fighter pilots, which started to not be able to contain their mass and did not attend their Weight Watchers and physical training as regularly as they should have, but now have got themselves where you have some of our aircrew who still have years left in the cockpit, but can no longer fly the Gripen, for example, which has a lower mass top end than the Hawk, but a lower bottom end than the Gripen. These are being corrected now through a project. Amount from the time that the approvals were done by Cabinet, and therefore on those funds were then ring-fenced by Treasury. So there could be no funding on the capital account outside. The challenge of the project team then, and out of this process where I again yesterday said you want the project team to be involved right through, one of the main roles then, once the decision is taken, in this case we were going to acquire the Gripen, then the project team goes into a amount from the time that the approvals were done by Cabinet, and therefore on those funds were then ring-fenced by Treasury. So there could be no funding on the capital account outside. The challenge of the project team then, and out of this process where I again yesterday said you want the project team to be involved right through, one of the main roles then, once the decision is taken, in this case we were going to acquire the Gripen, then the project team goes into a different approach. Now we know the product. We know the aircraft fairly well. We know the financial baseline. We know the delivery. And the job of the project team is then to ensure that we get the very best we can for the amount that is spent on that aircraft to meet the requirement of the Air Force. That is an important role that the project team continually is monitored, it's audited on, and that is why you report back regularly to the various boards on a regular basis and is audited throughout the process to ensure that that occurs. So I can then confirm that whatever was delivered had to be delivered within the ring-fenced amount. If you may remember, and obviously this will come out much more from the financials and the Treasury side, but there were certain aspects of the program that were not, call it, funded by the additional amount because the government had come in to supplement the long-term master plan of the department. So there was some funding that was additionally added for program management and other matters that came, yes, from the end user as well. But in terms of the deliverables, it was ring-fenced, and again, like in all projects, you have to balance the resources. And perhaps I should say it now, I had it a bit later. But if you remember, during the period of the negotiations under the International Office negotiating team, there was ongoing debate to contractually find this balance already. Log, number of aircraft, etc. And it went through a number of iterations, which in my personal view was an excellent process to go through. I can assure you as the project team, we were questioned on each and every aspect by that team to make sure that this balance and resource balancing occurred already at that point. And one of the affordability measures that was taken was the IONT came back via the project team to the Air Force to say, look, we need to review some of the functionality or the logistics or the numbers. And this was done in debate between the parties and then back through the IONT to the contractor in this case. And certain functionalities were then limited and stated as such. The Air Force accepted that and then said we must try to meet those requirements. And I can again compliment the project team that towards the end of the program, the decision was taken to reduce the aircraft from 28 to 26, but to rather deliver the full capability on the aircraft. This meant that the aircraft that we have received then did deliver the requirements that the Air Force said were mandatory at that point in time. And recently, when we used the aircraft for an operation, it was very interesting that the officer commanding of that squadron said to me, you know, it's very good that we delivered that last bit of capability. I can't elaborate in total on it, but it actually meant that they could carry out the mission a lot more effectively and efficiently. So again, I think I want to give the assurance that this is an ongoing challenge. You have a limited resource, but you try to make it the best at the end of the day for the end user and, of course, for the country. And this is a classic example where, in my opinion, that worked very well. Thank you. Both aircraft and modern aircraft that were delivered were not necessarily designed for all what we term in aviation anthropometrical data or anthropometrical models. The most extensive work done on this was by the Royal Air Force, and they talk about a 2 to 97 percentile in this domain. This is done by aviation medicine people, doctors and specialists. But the bottom line is what they say is they'll design an aircraft that anybody in the demographics of of that country that they either used their own or a worldwide one, and the RAF is the standard. Our aircraft were delivered to that standard, 3 to 97 percentile, meaning that within 3 to 97 percentile, it goes about the ejection seat, not necessarily only the cockpit. A large part is the ejection seat, because it is obviously a very critical component, and also the cockpit layout. These measure, in other words, arm length, leg length, mass, head size, etc., because of the fact that the cockpit is then designed to accommodate that size of person, etc. So when we do our flying medical as pilots, you get measured. In fact, you get measured electronically nowadays as well. Everything is going digital. And so this would then decide whether or not you pass your medical to become, first of all, a pilot, and then you have also, when you fly, you have restrictions on the ejection seat. Fortunately for us in the combat line, to fly the PC-7, it's got an ejection seat, so this is done early. So, but should any gender or race fit that profile, then it is no problem, they can fly the aircraft. So what we found then is we have so far managed to train, we have 3 female fighter pilots currently. One is fully qualified on Gripen and operational and has flown in exercises. And we had no problems. We have proven that from a gender perspective, there is no restriction on women in South Africa to become fighter pilots, and we're very proud of that. Then we have a strike navigator on Hawk, who flies females being lighter. Also, some of the candidates who we could not accept onto the aircraft, not for the ejection seat, but for some of the other limitations of mass in the cockpit for ejection, we could not accept into the combat line or for selection. And this now has then become a gap, and this gap is being filled currently by a project which will lower the bottom end mass for entry onto these seats on the aircraft, as well as increase the upper end. And the upper end of our problem was actually our middle-aged fighter pilots, which started to not be able to contain their mass and did not attend their Weight Watchers and physical training as It also fitted with 2, not 3. It doesn't have a tank under the belly. It carries 2 tanks under the wing. But with the aircraft having a less, the fuel consumption being less on the engine, it is exactly half that of the Gripen. Therefore, you don't need as many tanks because by virtue of the lower performance and the lower engine thrust, it is more economical, as is the case in all other aircraft of those 2 classes. But just to mention that it does have drop tanks for long-range ferry and for missions that require the aircraft to fly for longer. And then, again, part of the program was also to supply the Hawk with a helmet-mounted sight, which is similar to the Gripen's helmet-mounted display. The only difference that on the Hawk, it's only a sight. So, Chair, on the Gripen, the pilot will get the instrumentation reflected in his helmet. On the Hawk, he will only get aiming cues for air-to-ground and air-to-air weapons. So, again, being the training aircraft to lead the pilot and train him to go to the helmet-mounted display, call it the all song and dance on the Gripen, this capability is being delivered still onto the Hawk at the tail end of the project, and also will mean that together with the air-to-air missile, which will be delivered to both the Gripen and the Hawk and integrated under a separate project, the Hawk will also then get an air-to-air missile and a helmet-mounted sight. And I go back again to the staff requirement. One of the requirements in the staff requirement was that the aircraft should have what we call a radar sensing radar at least. The Gripen has a full airborne radar, as I explained, very highly sophisticated. But one of the shortcomings we found on the Impala and previous trainers was we did not have a ranging mechanism, which meant we had to spend quite a lot of time training the aircrew on the trainer in terms of range estimation and doing quite the complex task of air-to-air firing. It is one of the higher skill levels required in fighter flying. And so this was a requirement. And when we came to the evaluations, it was determined that neither the 339, the Air Macchi, nor the Hawk had provision for this capability. The L159 was not bidded with, but could be fitted with such a radar sensing radar. And when we flew it, we realized that there were some advantages to this as well. And so we did look at then, when the Hawk was chosen, to see how can we solve this problem and overcome this problem. And the decision taken by the Air Force at the time then was to make these 2 requirements mandatory for the Hawk so that we could cover that gap in terms of this capability. And although not on our Hawk yet today, both are currently funded and both will be delivered at the tail end. Remember, if I said to you the other day, although we've taken ownership and handover, Chair, and are satisfied with all the requirements, there are 1 or 2 elements of the program which is typical on such a project, which will come at the tail end. And obviously with the missile, we're waiting for the new missile. We're not going to now go and spend money on an interim training missile. We will wait and make other plans in the meantime so that we wait for the missile to be delivered on the Gripen and the Hawk, the same missile, again, to cut costs and be as cost-effective as possible. So once we receive our air-to-air missile and our helmet sight on the Hawk aircraft, then we will have overcome that problem, and the project would have, I believe, again, done very well to deliver that capability within the cost constraints. And also, of course, this will again advance the collateral capability of the Hawk, because now it will be able to better look after itself, which means that it could be employed with that growth in a more higher threat environment than it would have been had it not had those capabilities. So I just wanted to add that at the end of the weapons suite of the Hawk Mark 120 aircraft, Chair. Then, in general, both Hawk and Gripen are capable of assisting other services and sorry.
Before dealing with the general aspects, I see that the range of the Hawk is more than that of the Gripen, at about 2,594 kilometers. Can you explain that?
Chair, yes, remember I said in terms of range, you must match that to the configuration of the aircraft. In the Gripen, we gave the operational role with the aircraft in a typical combat situation. We're carrying the single tank and a mix of weapons. So that is the only reason why that is low. The Hawk figures we quoted here is for a typical ferry of the aircraft with all its tanks and not weapons on board. And there's a myriad of comparisons that one can do in this domain. So if you talk ferry range, the Gripen can fly a bit further. If it's got its 3 tanks and ferry range, it will fly a little bit further than the Hawk can. Again, considering the fact, as I said earlier, that the fuel consumption is about half on the Hawk than on the Gripen in a typical scenario. Thank you, Chair.
And you further mentioned during the presentation that the Hawk can carry a 12.5 kilogram practice bomb and a 4.5 practice bomb. What kind of bombs are those?
Yes, sorry. Because it is a training aircraft, Chair, when you train the student in the beginning and he's learning, you obviously don't want to be throwing expensive live ammunition, nor we do have training bombs as well that we use. We will only use live bombs on both aircraft, either in operations and then at certain times, if there's not been an operation, in order for our armorers to also handle and practice and be aware they are handling a live weapon, we will at time to time have demonstrations or then do some practice also that your pilots learn that he's now flying with a live bomb. But in general, you want to cut your costs when you're first training. So what we have is we have much smaller bombs that we clear on the Hawk. We clear them on a carrier which is a light series bomb carrier. It can carry 4 of these bombs per carrier, so you can carry 16 bombs on the aircraft in one training sortie, and you can go round and round and throw 16 bombs, whereas had we to load large bombs, we could only carry 4. So you'd fly a whole sortie to throw 4 bombs. Now you can throw 16 bombs, and these bombs have no explosives, and they cost probably about I would say if 100% for a bomb, you'd probably pay about 15% of that for the smaller practice bomb. So it's a very economical way in which to train the people on the aircraft. The reason why the Gripen doesn't carry it is by the time he gets to Gripen, he's fully trained in this aspect. So again, by having the training aircraft before the time, you also have the saving then on your full fighter capability, where you don't need to buy that capability onto that because he's trained already. There he can go straight over to the large bombs and the live bombs. Thank you, Chair.
So there are no practice or missiles and bombs on the Gripen?
No. What we do is if we initially throw the bombs, then we will just not arm them. So we won't put the warhead on, you put a type of trainer war on. But the bomb itself is the same bomb as what would be used operationally, yes. Thank you, Chair.
And you mentioned something about the fragmentation bomb, which is carried by the Hawk. Can you expand on it?
Yes, this is more in the domain of bomb technology. You get various kinds of bombs. You get bombs that are designed for different targets, back to the weapons effort planning. So some bombs are designed, iron bombs, they will make a hole through concrete and only then, explode and do their job. Others, you want to actually have a type of what we call an air burst, where you want the bomb to burst in the air for certain effect, and others you want to like on a bridge, you want it to do it on contact. And this is not controlled by the bomb, it's controlled by the fuse on the bomb, just like you would have a fuse in mining and all others. And the fuse then can be set to various different settings. It's quite a complex art, and that's why you have some of your members on the squadrons trained to a high level in this, and of course planners as well, and they will sit with the operational planners for a mission and decide on which bombs, what fuse setting, what timings, and also when you deliver operational bombs, you don't deliver one bomb at a time, you deliver what's termed a stick, and of course the system will calculate and you set the interval you want the aircraft to drop the various bombs at in the run, because it doesn't help you deliver 5 bombs on the same point. That's wastage. So you will get the right effect again by varying the number of bombs and the fuses mix on the aircraft. So in fragmentation is one of the versions of bomb and fuse combination that will create a certain effect, is where that term comes from, Chair. Thank you.
And you also mentioned something about is it the Vicon 18601E? What is it?
This was the reconnaissance pod, Chair, that was fitted to the Cheetah. It was a photo pod, not a digital pod, as is on the Gripen now. And what we did on the program, when this pod was taken on the aircraft, the decision had to be taken on Hawk whether or not one of the requirements of the Air Force, and also we used to have photo pods on the Impala, so it was a bit of a carryover to the Hawk, was to have a photo capability, A, to train the member, and also in a collateral role, such an aircraft, especially with a Hawk with a bit more performance, could be a very effective reconnaissance platform as well. So in order to cut costs, we determined that to take the same pod that was on the Cheetah, this Vicon, and integrate it onto the Hawk as a photo reconnaissance capability. In the interim, until the Gripen came with its digital camera pod, meant that we would not sit with a gap in the event of the Cheetah having to be phased out early. And that's exactly what happened in reality. The Cheetah was phased out a bit earlier than was expected. And for that reason, we were able to retain at least then a photo reconnaissance capability on the Hawk at very low cost, because all we had to then expend some funds on was to integrate it onto the Hawk. It fitted on the centerline station exactly like on the Cheetah, and we fitted it where the gun pod was. So that we didn't need any extra much design work or anything. We just needed a test clearance. So I believe it was a very effective, cost-effective way of retaining that capability. Unfortunately, in a way, photo reconnaissance now is almost at its end worldwide, and the limitation has become the film. I think you all are aware of the hazards of the materials that are required to process photographs, and they're not very environmentally friendly, and so we found then that the film has actually become the limit. But we did, as part of the, we knew this was coming, so when the Hawks were delivered, we did a bit of a long-term buy of film for the Hawks. So currently we can still operate the Hawks for about another year or so on the photo recce, but we know already now that that capability is already proven on the Gripen. So we did not end up with a gap, and I think that that was prudent planning that we did on the project with the Air Force to just cover that gap then until the digital era had arrived. The other advantage is that same pod on the Hawk can quite easily be changed from photo to digital without acquiring a new pod, and that would again be a typical product improvement on the Hawk to go also to digital, should that be a requirement for the department from time to time. So I think this also strengthens what the Navy, also my Navy colleagues, and what General Malinga alluded to. We never stop in the military to look to improve our products and make sure, because they have to operate and fly over these long periods, 30 to 40 years. So you will find from time to time, and then we put in this requirement, and then it's up to the senior decision makers to decide, is this necessary, and is it cost effective, and are we going to do it now, or is it going to be done later, depending on other requirements. But the task of the squadron all the time is they will continually, through the life of an aircraft, come back and say, there's a possible gap coming here, because they operate. So these requirements can come from any level, and then they get drawn up into all of the whole departmental planning process to continually look at cost-effective ways. Now, again, this is important to look at when you talk about growth capability on a platform. And so one of the factors that you would look at in acquiring aircraft again is, does it have growth? And I think what we've seen here, we've already seen our Gripen has gone to the NG in Sweden. There's a future. They're not stopping now. They've already gone to another, which is also good for the users of the old system, because it means the company is going ahead and there's development. Similarly on Hawk, it is still being out there and has this growth capability that we're able to apply on the platform. So I think that's also a positive on that one. Thank you, Chair.
So, in other words, the capabilities of the Hawk are more than just for training.
Yes, the capabilities are more than just for training in those collateral roles that I've alluded to. Yes, definitely.
The type of engines that you acquired for the Gripen and the Hawk, are there any advantages that we gained from them?
Yes, I think I've mentioned before, let's start with the Gripen. The Gripen engine that was in the bid was the RM12. This is a Swedish Volvo derivative of a General Electric 404 engine. It's the single engine from the American F-18 program. A very, very reliable engine. And I must say, I'm not sure about the motor cars. I've never driven one, but I do believe that Volvo engines run well, and we've seen that this is so as well. This is a very proven engine worldwide, and it also has this eco-cruise capability. So you find that in many cases of the design of the aircraft, it accelerates very quickly in the supersonic domain due to this very efficient engine combined with the aerodynamics of the aircraft. And also, it has the mode that I spoke about, the training mode and war mode, so that you are not unnecessarily overstressing the engine if you don't need all of the features. This is also new, that we have not had on our aircraft before. And lastly, probably one of the big advantages of modern engines is how quickly you can change an engine because they are modular. So on these engines in the past, our engines, you had to send the whole engine back to the manufacturer if it needed deeper level or got very bad damage. Or you had to take the whole engine out of the aircraft and repair it. Now, you only have to take one of the modules out of the engine. The other major advantage is that the modules are interchangeable. So if I take a module out of aircraft A's engine, I can immediately put another module in and carry flying while I fix this module. In the past, that aircraft stood because the whole engine had to come out. And you either then had to have a whole engine to put into the aircraft or not. So in the case of the Hawk, we actually did not buy any additional engines. In the past, we would always have bought additional engines with the older technology engine for that reason. So that is a large cost-saving and logistically advantaged type of engine. I think that's a summary of the engine in the Gripen. What happened on the Hawk was interesting, in that the aircraft was bidded with, at the time, the Rolls-Royce Adwa 871 engine. And during the bid, when we flew the L159 in Czech Republic, it had a modern F124 engine fitted to it. It's a Honeywell, an American engine. And this engine had digital control. It had very similar features to the RM12 engine as well, a excellent engine. And we also then found out that the Australians had also, when they got their Hawks, looked at possibly fitting this engine to a Hawk. And so once the evaluations were over and the Hawk was chosen, during the negotiations of the IONT, the project team with BAE, we had a trade-off study done between the 871 and this F124. And the outcome was that Rolls-Royce then decided to also bid their 951 engine, which was just coming out of its developmental phase, which had digital control very similar to the F124 engine. And so this trade-off was done. I can say that it came out very close in terms of performance. And the advantage was that the 951 engine, because it was an upgrade of the fitted engine, did not require any airframe change. The F124 would have required some changes to the airframe, and that is why it ended up being, the only reason why it ended up being more costly. So clearly, the lower cost option was then followed, and that trade-off was then accepted by Rolls-Royce. This meant that we got an engine with an additional, the 871 engine produced 5,700 pounds of thrust, the 951, 6,500. And although that might not seem a lot, but in that bracket on the upper end of performance, it's large for an engine. The other advantage is it had what's called full authority digital engine control. In other words, free handling as the engine in the 124. And its specific fuel consumption was actually better than the 871, despite the fact that the thrust was higher. So the bottom line is that for no additional cost to the program, we got a far better engine in our Hawk today than that which was bidded initially on the bid. And again, I think that is the advantage of taking that year and negotiating in detail with the manufacturer, and that was, of course, done by the IONT in conjunction with the technical teams which we were involved in. And we were then able to, which is the job of a project team, to deliver a better engine at the same price on the aircraft. And I allude to this later. One of the weaknesses that the Air Force had all along, and you can go back to I'm sure any fighter pilot at all our reunions, everyone will tell you the same. South Africa is harsh. Our airfields and our military bases are all at fairly high altitudes. Many of other air forces operate their high-performance aircraft at sea level. Ours operate at Waterkloof here at 6,000 feet, compared to, say, Durban or the coast. Now, an engine like your motor car, you can imagine in a fighter aircraft at that high power setting, performs a lot higher at the coast than it does at 6,000 feet. So we've always had what we termed problems with hot and high. And when it's very hot in South Africa and you operate at a high altitude, obviously the performance of the engine is largely reduced relative to the coast. This extra thrust that we got overcame that problem. And the same on the Gripen again, because the match of the thrust to the weight of the aircraft and the design has meant that we can now operate off much shorter strips, much shorter runways, and also more efficiently at hot and high, which is probably going to constitute 90% of our operations in this country, other than if we'd go to the coast and it's very cold, but generally we're in hot and high conditions. So the engines also helped with that. The other advantage is now, of course, again in terms of training, the air crew have been operating on an engine similar to the one in terms of technology and usage as the Gripen. So again, it cut the training gap even further between the two aircraft. So I think that was one of the big pluses of the program was the improvement in the engine on the Hawk, as I said, at no extra cost. Thank you, Chair.
And the avionics, you've alluded to that. Are there any differences between the avionics in the Hawk and in the Gripen?
Yes, Chair. The avionics of the Gripen was a given. So when the bid was done on the export baseline, those avionics were accepted as such. We did have, when one acquires a fighter aircraft, and part of the initial project is what is termed, a man-machine interface committee. This is chaired by your test pilot and your operational pilots together. And they sit with the contractors' test pilots as well as any other experts, engineers. And they look at all of what we term man-machine interface. You can't impact on the actual displays or change the design, but you can choose, for example, if I may be very simple, on a particular screen or page, like on your computer, you can make changes to color, types of symbols. So if you want an arrow to show the heading that you're going to go in a direction, you might want to use a different symbol. You have a certain amount of flexibility with the contractor. And this is normally put to cost, man-hour cost, and then you make sure that you best meet your training requirements between your various platforms. And if you look at American aircraft, you'll see they like doing something from history or for good reason that suits them. The Eastern aircraft, when we flew sometimes there, then they are in kilometers, they're not in knots. And they put their height in feet and not in meters and not in feet. So this would be a major change for you. So in all aircraft that I think this happens. And so this was done. On the Gripen, this is what occurred. We had a limited capability to say, well, although the export baseline that you've designed but we would prefer to have, and that was agreed up front, and that's what you got. So again, it comes back to this involvement throughout the project is very important. So that's the avionics on the Gripen. They were given. They are Swedish a company that supplied the avionics suite to the aircraft. What happened on the Hawk again was BAE, in bidding the Hawk, as part of the defence industrial participation, elected to look for a South African local company who could supply the avionics. The general rationale with the leading fighter trainer was to see if work could be generated as well for South African industry, because it was the trainer at that level of capability. And so, again, another trade-off was done with 3 companies, and the company that turned out top was ATE in Midrand, Advanced Technology Engineering. This was a company that had already in South Africa done work on the Mirage F1 for Spain. They actually got a contract to upgrade some Spanish aircraft and make some changes. They were also heavily involved with the department and on technology programs previously. So this was an excellent opportunity to bring to fruition technology money that the DoD and the country had invested in local industry, to actually bring it to a product to our own advantage. And this was agreed to. And this was the first time ever that BAE Systems, which is, as you know, a major aerospace company, it's the first time ever on any of their 18 variants that they were prepared to fully subcontract the design and development of an avionics system on Hawk to a subcontractor. So this was a first for South Africa and for this company. So this was big. This was a development from scratch of all the software and all the equipment for our Hawk. And this program was launched and ran successfully. And the biggest advantage here is we could now have full say on the avionics man-machine interface. So what we did is we made it exactly the same as the Gripen. So in the Hawk cockpit today, you have a Gripenized Hawk cockpit. So when the pilot starts his training, throughout his training on Hawk, and he wants to select the radar, and he presses a button on the stick, it might not have the same, what we term, tactile feel, but it's the same button in the same place. And the screen will change the same as it does on the Gripen. When he wants to select a weapon, fire a weapon, it's the same button or control in the cockpit in the same place as it is on the Gripen. And I don't think I need to allude to what an enormous difference this is going to make, because when he gets to the Gripen, one of the biggest challenges in many other air forces that did not have this opportunity of the two together is they have to now retrain that pilot on different controls and different symbology and a different avionics system. We could then tailor this to minimize the gap in this regard. Not on every instrument, because the Hawk still has also some analog dials and others that the Gripen doesn't have. But in terms of the avionics system, this really became a major achievement, I believe, and also has had impact. And, of course, gave our local industry 1/3 of the airplane almost, because generally these type of aircraft is made up of 1/3 airframe, 1/3 engine, and more or less 1/3 avionics in terms of cost, in terms of effect. So that also means that we also have a local company now that can support our Hawk avionics system to a large extent. So I think that was a very positive part of the program as well, Chair.
Thanks, General, for that. Could you then go to General, paragraph 41?
Yes, I just allude here that both the Hawk and Gripen, Chair, are capable of assisting other services and government departments, not to the same degree, of course, than our helicopter and transport counterparts because of the nature of the game. But that doesn't mean that because you have fighter aircraft that they cannot serve the police, the army, or the navy, or special forces, and of course defense intelligence in terms of that part of the capability, as well as take part in multinational exercises and operations. And I will, during the utilization, I will allude to these a little bit more. But when it is required, and whenever we can, we are positioned to support these other services. And typically this will be for command and control purposes, surveillance, as I've mentioned before. So while our aircraft are training and flying, they are doing tasks of normal reconnaissance, either be it for intelligence gathering, for information, for maps, upgrading power line positions, upgrading how populations can move, etc., because the aircraft can, of course, do certain survey work as well at high altitude and high speed. And so, therefore, we contribute to many areas which are relatively hidden in the domain. But they are out there. And so while these aircraft are doing force preparation, etc., they are also carrying out support to other government departments in these domains. Border Patrol, of course, which, as was alluded to, was given back to the South African National Defence Force a few years ago, and the Gripen has played a role, particularly at night, as well as the Hawk in this role, both from the visual, photo, and digital reconnaissance capability. And if any of you were at the go to the aerospace show that is held every 2 years. Last year we had some footage from the Gripen flying at very high altitude, and you will see there that this is no less than what very, very sophisticated air forces in the world can do in terms of capability and in terms of what we call resolution and the equipment. This is really a world-class capability that we have on the aircraft. It is, however, again, not for area surveillance. This is for, shall I say, specific task surveillance. This is not to do what satellites do and what other platforms do. It can't be replaced. But it can do it at high speed, and it can do it quickly, and it can cover a large area quickly, which from time to time is necessary. Because very often, the slower aircraft or the satellite, if someone wants to do something, they'll know when the satellite's overhead. They're not going to do it when the satellite's there. Satellite, and they know those times. They don't know when we're coming. We'll come faster and high and quick. They don't know that the aircraft are there. So I think that is also a, call it niche capability that we can carry out. Search and rescue. Very often in search and rescue, one of the problems is it happens as Murphy has it. It doesn't always happen in the nicest of places. It can happen in areas where the communications are very poor. Ground communication is not good. Line of sight is not available. We can put an aircraft such as the Gripen or the Hawk very high, sit at 48, 50,000 feet, and you can imagine the range at which you can communicate. So we become like an airborne post office then for a search and rescue, or we can sit on the coast but talk to a ship very deep into the sea from that height due to the capabilities of the aircraft. Very useful collateral capability. In particular, one would use the Hawk because it's more economical, but if you needed the extra digital part, then you use the Gripen. And then that is basically what this communication support, or what we term in operations, would be the Telstar. Before I go over to utilization, I did mention earlier about the two aircraft that can fly together. And again, because the avionics was tailored towards the Gripen, we could also look at, for example, common radios. So some of the radios in Hawk and Gripen are compatible and can talk to each other. And for that reason, it gained the capability. This was something you find out, like I said, later. You don't see this necessarily up front when you evaluate. You only pick it up later in that particular platform. Not to say that some other aircraft couldn't have done it, but we know that this can be done by these platforms, which is an enhancing feature on the two aircraft. Thank you, Chair.
General, the fact that there was a reduction of the Gripens from 28 to 26, did it in any way affect the mandate or the capabilities?
Obviously, having two less aircraft means you don't have as many aircraft in a all-out capability. However, when one looks at the reduction of the aircraft and what it then delivered in all of the aircraft, in terms of those capabilities, I'm sure if you speak to any, and certainly any squadron commander or pilot, he will tell you, rather give me a few less aircraft, but with the full capability. And this was quite interesting in that the Swedish Air Force also did not have all of these capabilities in their earlier version of aircraft. And when they went over to the upgrade, Chair, to the EBS model, they elected, I can't be in detail, but they elected also not to take a certain mode. We ended up having that mode delivered due to this reduction, interestingly enough. And when they had to operate in certain areas, they found this to be a problem. Whereas in our operations recently, we found with this capability, we were then able to complete that task. And it was very interesting after that how quickly the communication happened. And now, again, I'm coming back to the importance of user groups and having other users of the aircraft in this domain, out of sanctions, where one can talk easily and gain. It just adds to the ability to grow your aircraft and your capability without, of course, compromising in any way. But I'm just saying it is very important that you have capability on these platforms as full as you can. If that answers your question, Chair.
Thanks, General. I know it may be relevant to utilization, but there were critics. Critics were saying that at the time when we acquired the Gripens, there were only 9 fighter pilots on the Cheetah. And they are of the view that there were capacity constraints to fly these Gripens. That's why at some stage there were talks of deferring the acquisition of the Gripen. Can you speak to that?
I am not aware ever that I'm not aware of any rationale or decision to delay the acquisition of the Gripens due to the fact that regarding pilots. What I am aware of is during the year of the negotiating, when the IONT and the department had the task to fit all of these programs into a fixed ceiling, a lot of considerations were given to aircraft numbers, go ahead, don't go ahead. And as you know, during that period on the fighter programs, the tranche approach was introduced, tranches 1, 2, and 3, which would deliver the aircraft in tranches with a call it opt-out clause for the aircraft in the deeper tranches. And so, yes, there was a lot of debate around this, which should happen in your negotiating phase, and which was again done. So in that debate, certain iterations would have been discussed. But I must say that from my level, and where I was involved, I never heard the reason of not enough pilots being a reason to delay or to tranche. It came from other factors that was, of course, discussed, some at my level, but many others above my level as project officer. So I cannot give a definitive answer on that. All I can say is where I operated, I never picked up that this was a factor why one would want to either delay or go to that mode of delivery. Chair. Thank you.
In the event that you wanted to add the 2 Gripens, was there an offer that could have been provided at the same price within a certain period?
My experience as a project officer tells me that any time you want more aircraft, there will be a very willing response from any contractor, yes. The advantage of that, of course, is that your development or your sunken cost in your initial buy has been done. So obviously, if you wanted to add to a fleet, this is worldwide, then obviously your cost to value is far better in terms of your initial buy, because you don't have all the other factors involved in that. So I would believe that if one wanted to look at expansion, if that was ever becoming a requirement for the department, then that would be the first port of call, is to see what would the cost be of acquiring the same baseline and the same type of aircraft. Chair.
Thanks, General. I think we can now proceed to deal with utilization. I think in paragraph 4, it is quite apparent that the utilization of these aircrafts was as provided in the white paper, the defense review, and the staff targets. Am I correct?
Yes, Chair. I think one can say that in the performance of the Hawks and the Gripens in the SAF since delivery commenced, we can measure. We have a measure or a baseline to go back to. That is then, as you correctly said, those documents, and I refer again. Not going to go back to it, but to the staff requirements. Because in the staff requirement, the Air Force will give the best estimated average flying hours per year. And the Air Force very much works on flying hours per year as a baseline per type of aircraft to predict all its costing, funding, resource planning. We obviously manage and control every hour, in detail, but in general, in a planning and budgeting cycle, to compare apples with apples, you give a number. Because also in your staff requirement, that will be converted by Arms Corps into many other factors that the contractors have to reply to, both throughout the contracting and RFO phase. So, and again, this is a best estimate of the average over normally the 30 years. We use a 30-year cycle. We know in the Air Force, however, that we virtually always fly our fighter aircraft a lot longer, for a longer period. And so this will start off at a conservative number normally being much higher initially, because you don't know when the aircraft is going to be in conflict, only in training, ramping up, in a low ebb of times, and so it can be very variable over the years. But it is stated in the staff requirement, and the final number that was amended and came to on the project was that the Hawk then finally was designed to fly 4,000 hours a year and the Gripen 3,000 hours a year. That is what you will find in the final user requirement statement. It won't be in the staff requirement because the staff requirement stays the same. The user requirement specification, the real detailed document, is a living document. So you may find during a project, Chair, that the URS undergoes a change. If that change is minor, there's a set process it goes through. It goes back normally to the arm of service for approval. If, however, it impacts on the force design, then it has to go back to the highest authority. And this happens in your normal project domain and through the process. And so the final decided amount then for the two aircraft types was the ones I gave. 4,000 hours for the Hawk and 3,600 for the Gripen. The current fleet then of... and also the Gripen and Hawk systems are an integral part of the South African National Defence Force and SAF capability to meet its air defence and other mandates, as in the White Paper and the Defence Review. The current fleet of 26 Gripens and 24 Hawks currently are adequate numbers to meet the above mandate as currently required by the South African National Defence Force. As we alluded to, it is not yet at the numbers of the 1998 approved force design. The current force design 2013 is underway, and it may come to these numbers. It may come to something slightly different. We don't know. Once it is approved by the correct authorities, exactly your point you mentioned earlier, if it is decided that more are required, then at a point in time when the department applies or the need is there, then the decision will be taken. So I cannot expand on that other than to say, as I did yesterday, that a force design is an ongoing, and we're seeing this in our own country now. But currently, we believe that the current numbers are correct and meet the requirements that we have to carry out our mandate. Fighter air and ground crews have been well trained and developed and are capable of operating and maintaining these aircraft types. This we have shown that we have, with the training that was put in place by the project and our ongoing training, our instructors have trained our own crews without the original, without the contractor, on their own, and those people service our aircraft and work on our aircraft. And we have made good use of the training systems. And we have also then developed our own, what we call standard operating procedures on the unit to expand on this capability, and we can do all the necessary logistical services as was per the requirement on the base. We've also delivered the
training of the air crew, is it local or do they have to go to the manufacturers?
I think I alluded earlier. Chair, is that better? Thank you. I alluded to earlier, the air crew for the Hawk were all trained in South Africa at Air Force Base Makara. There were 6 air crew initially trained, all instructors, experienced instructors, either having previously flown Cheetah or Impalas, And they were what was called the initial cadre. You normally have an initial what's termed the initial cadre, trained by the company. Once they are trained, they then continue training your own aircrew, but under the auspices. So in the case of Hawk, BAE Systems sent out 2 instructors. These are normally military instructors that they employ, ex-experienced military instructors, and test pilot mixture. So you're getting both, and they train your first 6 pilots. Then they stay. One of them stayed on for a year to help with the development of our syllabi and our curricula, and also to be there just to say, well, because now we start to expand the training. Our pilots will now start to do things our way. They may say, you might have done that on an Impala, but you can't do that on a Hawk. So you don't just leave your own aircrew. There is a controlled process because of the safety aspects and need for that. And so you find that you keep on site for about a year one of those instructors which the project leaves for you. And he then helps, and when you're satisfied, then he's relieved of his duties and he returns, and then you call it go on your own. And this was well done on the program. From the Air Force side, we had no problems, and we now fully train our own. We don't have any instructors from the manufacturer. In the case of the Hawk, with our close ties with the Royal Air Force, a very wise thing was done by my predecessors at Combat, and that in about 2003, the South African Air Force entered into an instructor exchange program with the Royal Air Force. They have been operating the Hawks the longest. They are very experienced on the aircraft. So we sent one of our instructors over to do a 3-year tour at RAF Valley in Wales, where they train all their Hawk pilots. You can imagine the advantage of gaining all of that prior to our initial training. He then came back and added to that information and that experience that we had. And they then also sent us in exchange an instructor. So we had a RAF instructor. The advantage for them is their instructors were still flying on the analog Hawk because the RAF had not yet got a digital Hawk cockpit. And so, or this version of Hawk. So they gained the advantage that they could send one of their early instructors who knew the airframe well, but now he could fly with our modern engine and our modern avionics. And that I must, again, applaud my predecessors. It was an excellent move. And to this day, we have continued that exchange. We have a Royal Air Force exchange pilot, and we have our 3rd exchange pilot in the UK on a continual basis. And this is also, I must say, one of the advantages of being in the new South Africa and out of sanctions is we have these wonderful opportunities to do these things and to learn more from others and broaden the scope. So that was the case. The ground crew is exactly the same. They came, they trained our ground crew on the computer-based system, on the aircraft, and then they leave behind what is termed a field service representative. The bigger companies do this. Similarly to the instructor that stayed, this is a very highly experienced engineer, logistician from the company, and the project then keeps him on for the Air Force for about 2 to 3 years. And his role is exactly the same. He helps to fault find and to do deeper level and to carry on that initial training that is done by the contractor until such time as we are comfortable. We also had an engine, because it was a new engine. We also had someone from Rolls-Royce, which the project put on site, also a field service representative, and the same from ATE. So for each of the 3 areas of the aircraft, we had an experienced engineer from the company on site for about 2 to 3 years. Now we, of course, take handover, and now it's time for us to be on our own. Again, should we find a problem, we will always have the umbilical cord back to the company to call again if we need help. But obviously, it's a cost consideration as well. And of course, your own ground crew want to carry on their own. They don't always want someone from looking over their shoulder. They take ownership. The wonderful thing about delivering as a project officer is when you give that system and you see your men and women out there in blue. They just want to take this, and they become proud of that system. And then they don't want the contractor there anymore. No, don't come and tell us how to do this. We know. We've been operating jet airplanes and fighters since way back. It's wonderful because it's called the pull of the end user. The project, you must push them now, and they pull to take ownership of the system. And that's where we are. We've completed with Hawk and Gripen the same. I assure you, my Gripen technicians, they were very thankful, and the training is excellent. We can get to that, but the same. They want to operate the aeroplane on their own and take responsibility, which is very healthy in the military and in the environment. So I can say that is how the training worked, and we trained adequate. And of course, the ground crew now train our own ground crew to carry on.
Before you proceed, the fighter and ground crews, are they part of a squadron?
Yes, a squadron is a unit and an entity that can operate the aircraft and carry out what is termed operational and essential intermediate support on the aircraft. Basically means that they can turn the aircraft around on the flight line. They can service it on the flight line, refuel it, do the checks before, after flight, do the ejection seat service between each flight, check basics on the aircraft. When the aircraft then returns from a mission and is reported as unserviceable, it could be a repair, it could be a fault in the system that needs to be reset, or a tire might need to be changed, which they'll pick up after the flight. Then the aircraft is removed from the flight line and taken to the servicing section at the unit, at, in this case, 85 or 2 Squadron for a Gripen. And there you have now your more experienced technician. He knows how to find this fault. He knows how to repair the aircraft. As long as it can be done, normally this would be done in about at least 1 to 2 days maximum on the squadron. So there are adequate ground crew at the right competency level trained to do that on your squadron. The pilots, of course, all operate at the squadron, and then each squadron also has intelligence officers, they have personnel officers, they also have engineers on the squadron to assist them, and they also have other staff, support staff, that are on the squadron. And everybody that walks through the doors of the squadron in the morning puts on the squadron badge. They have the esprit de corps of that squadron. They belong to that squadron, which is very important in the military, and it's the same on a ship or on a corps in the army. This must be fostered and kept that way, and it is in the Air Force. Then you have what is termed deeper level maintenance. This is where you're starting to need a higher level of maintenance, and also possibly this is where your company representative initially or your local industry could become involved, and that is at the air servicing unit in the Air Force. This is the deeper level maintenance on the base, and then the aircraft is taken or towed from the unit to this entity on the base, and they carry out what is termed then the intermediate or deeper intermediate type of servicing. All aircraft have to be serviced either after a number of flying hours or after a calendar. The Hawk is on calendar, the Gripen is on flying hours, more modern aircraft. The airframe on the Hawk is still calendar-based, but the engine and the avionics, being more modern, is time-based, which of course is much better, because often if you don't have calendar servicing, it means you don't have to service if you don't fly the aircraft. Another big saving and advantage of modern aircraft versus aircraft of the past. So then it will go to this unit, and it will be repaired there until it is fully serviceable and brought back. Normally, if an aircraft goes to the servicing center, it can go straight back to the flight line and fly, and any pilot can fly. But if it goes for deeper level servicing, when it comes back, then we have on squadrons a certain number of what we call maintenance test pilots. These are pilots who are not experimental, not full test pilots who can fly new aircraft that are designed, but they are there to do maintenance test flying, which means if the aircraft has, for example, removed parts and put them together, then this maintenance test flying will fly the aircraft for one sortie first, just to make sure, because he's trained before you put it back on the squadron. That's another sort of specialist job on the squadron itself. But yes, all the people, when I referred just now to 2 Squadron or 85, to the numbers of people, etc., that on average are at the squadron, you will see there that is then the capability at the squadron. That excludes then the people who are at the servicing unit. And then, of course, Chair, on the base is things like base armory. On the unit, you don't leave ammunition on the unit. The ammunition has to be obviously stored in certain positions, protected and safeguarded. So that is a base responsibility. So the base support will also need certain amount of training when you get a new aircraft, because the aircraft will use the bomb or configure it slightly differently. So there is a large amount of training on the base as well that takes place, and some of the people involved in the system are also then would fall under the base commander and not under the unit commander. I hope that answers your questions.
Now you may proceed and to take us through.
So we've spoken about the training and the ground crew and the air crew in terms of their development. Then all necessary logistics support elements, including facilities at the units and the base, and the deeper level SAF agencies, that's the ASUs I referred to for the maintenance, have been or are being delivered. In the case of the Hawk, it's all delivered at Air Force Base Mikado, and I alluded yesterday to the auxiliary power unit, which is being delivered here at Waterkloof. The reason for that is we put it at Waterkloof because this APU capability for Hawk can also do work for other aircraft in our fleet. So we've put it centrally. So you always look on projects, where else can this equipment be used in your Air Force and in some cases in your Defence Force? There's some test equipment that we actually acquired for our aircraft that the Army or Navy can or could make use of in the future. So then you would rather centralize that equipment at the place and then send that equipment into there. But the big thing is it's in the Air Force and it's local, which is good. I think the other point I want to make here is that, again, due to us acquiring both aircraft, there are certain of the test benches that we felt was better to acquire from either BAE Systems or Saab and adapt them for the other aircraft. So instead of buying two sets of ground support or test equipment, we were able to buy one set and just add the other requirements to do that test. An example that we have is what we call the hydraulic rig, which is for the Hawk and the Gripen. And it can test something like 168 components on Hawk and Gripen on a single bench placed on the base at Mikado. Now, this might not impact on everybody, but I can assure you that in the game of aircraft maintenance and logistics, this is an enormous cost saving. To have one piece of equipment for two different sets of equipment or aircraft of different classes bought from two different companies, and yet you can combine it. And again, it's because mainly it's computerized and is digital. And so the two projects, not only did they look in their own domain, but the two projects worked very closely together. When we were in the UK, we had regular meetings with our counterparts in Sweden, and they would come over to us to look at all of these aspects, to try to maximize the commonality, not only on the aircraft, but logistically, test equipment, and training and all those areas, which I think is important to mention. Then the local industry has also been empowered to supply equipment, test and maintain and repair. We term it M&R, is the maintenance and repair. The systems at deeper level, where this was not cost effective in the Air Force. For every single component on the aircraft that is not what we call a consumable, a tire is a consumable, a seal is a consumable, similar to a car, brake pad. But when you talk about a hydraulic pump, or you talk about a gearing on an aircraft engine, this sort of stuff, or equipment, we took each one and we did what's called a maintenance policy study. And on each of these maintenance policies, we did a trade-off between in the Air Force, in local industry, send back to the vendor. Remember, not everything goes back to BAE Systems. BAE Systems have many vendors who make their equipment as well. And so you can either send it back to BAE to the vendor. You can, of course, also alternatively send it straight to the vendor. This is very much in the Arms Corps domain, and they make very sure for us, as our contracting, even in service, they will make sure that the most cost-effective route is also followed in terms of the financial part. But the military look at what we call a maintenance policy, because there is also a strategic matter to this. It's fine to say it's more cost-effective to send a piece of equipment offshore. But if it is critical to the serviceability of your frontline fighter, you may elect to invest some additional money in that capability, because it could keep your aircraft on the ground, so it is then strategic. Now, each of every, and I almost want to say on every component, this trade-off study is done as part of what is called the logistic support analysis, which comes up with a logistic support plan, which the project does and delivers to the Air Force or to the end user. And this was done to, I believe, to a much deeper degree on these programs than ever before. And we can see it now. So we are continually reviewing those maintenance policies. In the beginning, around about 80% of the Hawk today and 60% of the Gripen maintenance repairs either done on the base or in local industry. And again, I say is a credit to the project work done during the phase. This implies that currently only 40% on Gripen and 20% on Hawk of that equipment has to be sent offshore for major repair, if it has something. And of course, you can understand with rate of exchange, import, export duties, shipping, statutory costs. This is, again, something that you strive to do as best you can. However, in order to do it on the base chair or in local industry, of course, you have to put down that capability as an initial acquisition. And again, I come back to that process of IONT, continual logistics, looking at the costs and the trade-offs. This is how the job is done. But I don't stop there as Director Combat Systems. We continually go back and review those same impulses with our local industry, with Arms Corps, looking maybe, has things not changed? They may change over years. They may become less expensive offshore. They may become more expensive offshore. And so then we could have cases where we will change those. But I want to give the assurance that this is not done lightly. And a lot of work goes into ensuring this. And this was done to quite a large extent for the country. You will hear more about this in the presentations, I'm sure, from Arms Corps and from DTI on the, I can't speak at all on NIP, but I can speak for the direct industrial participation, because that impacts on my product. I can see it. I can see that deliverable. And I want to say that on particularly on the Hawk program, for which it was intended, the lift irrespective, that quite a large degree of capability and work, in fact, a very large degree, was delivered through that direct industrial participation program as well. Not a chair with the details thereof, but we see it as the end user. To give some other examples, I mentioned the assembly line at Denel. So by assembling the aircraft means that Denel Aviation know that aircraft very well. You cannot assemble a sophisticated aircraft and also not grow your capability. So should we ever need Denel Aviation to assist us at a very deep level, it could be that they could do some work that possibly in the future we would have maybe had to send overseas. We haven't got there necessarily yet on all, but there is work and contracts on Denel Aviation as well. I mentioned some of the weapons that are made locally. All the fuses for our bombs are made locally at Reutech, and this is also a lot of good work being done there. And many of the other aspects that are still supported by our local industry. Again, not necessarily directly on the aircraft, but on the surround of the aircraft as well. There are things like covers for aircraft. There's a myriad of smaller equipment, vehicles that have to support these equipment that are specific to type. These are all then gained through local industry wherever possible, and in our case, most of it is. So we also were able to, of course, take some of the equipment from our old systems and adapt them cost effectively. The bomb loading carrier is a typical example. These would have been very expensive to buy from a company like BAE Systems or Saab. We then took our old Mirage ones or Cheetah equipment and through local industry adapted them to be able to do this job at minimal cost. So really the project, what I'm trying to say is looks across the board to ensure that we are cost effective and use our local industry to maximum effect.
In paragraph 44, you deal with the composition of the air and ground crew. Can you take us through that?
Yes, Chair, I can say that the total air and ground crew at the two combat units, on average, I unfortunately cannot allude to the exact numbers. That is sensitive, but I can say on average, over the period that the aircraft have been in operation, the number has been 232 members total, and as I said, this is for the total at 2 Squadron and 85, not on the base or at the air servicing unit, but these are the two core capability areas and units. And I refer to my, the reference is page 108 of JWB7, where it shows a table of the breakdown of the representativity of those members, and the details of that is then from the date of delivery to the date of the attachment for the two aircraft. And you can see there that approximately 41% of the members, are white, and the other 59 are what we would term non-white male. The females are also included in other as per the representativity as we presented to our department. The two figures, sir, are for 85 Combat Flying School on the Hawk and 2 Squadron for the Gripen, and then the total. And the graphs, unfortunately, not sure, sir, Chair, if yours are in color, but the higher bar is at 85, and the lower bar is for all three is at 2 Squadron. That's purely because the Hawk is fully accepted and is in a more advanced stage of delivery. So there are more people currently. As 2 Squadron grow, their numbers will also increase a little bit. And the advantage again is in many areas we can move our ground crew from the one to the other aircraft with very little bridging training, particularly on the engine and on the avionics, because it's on the airframe. Clearly, you can already see there is a vast difference. So it would take longer to convert a airframe fitter from a Hawk onto a Gripen because of the complexity of the airframe. But in general, those are the figures as we were requested to supply to the Commission to give an idea of the size and shape, and I think also to show that we're not there yet in terms of our representativity, but we have been working very hard to get us there. It is a continual imperative from government and our department, and I can say that since receiving the aircraft and tackling this since 2009, there has been a steady improvement in our figures. And they, in fact, at the last visit of the parliamentary committee, the units and the directorate were assured that cognizance was taken that we are on the right path, and we will achieve this in the years ahead. And this is an approach across the board of air crew, ground crew, and other support staff. So we are fairly proud that it's shown that, again, these two systems do not have any limitations in any way of representativity or gender, Chair. Thank you.
Thanks, Chair. I see it's about 1 o'clock.
We'll adjourn for an hour, and we'll come back at 2 o'clock. Thank you.